YouTube channel open करो. Hi everyone, good evening. Let me know, am I audible and visible to everyone? Tell me, am I audible to all? Am I audible to all? And yesterday I had given a challenge to everybody, right? That logic you need to solve using a string. How many of you have tried? How many of you have tried? Tell me. And till then, what I'm doing is that today I have a new setup. You know, you're supposed to congratulate me. Okay. Now we know that what are the problems we are solving, they are not the random problems, right? They are in a sequence of series that we have already planned to crack. A lot of interview in MNCs, in a lot of interview in the product based companies, in service based as well, right? And the planning we were following is, the agenda was, you already know that we will have a sequence of problems, a hierarchy of problems. Right now we are targeting what? Math, right? We'll solve around 7 to 10 problems on it, and then we'll move to array, and then after that string, two pointer, sliding window, right? Which you know, sliding window, prefix sum, and a lot of many more concepts. And these concepts, you will solve the question in a sequence. What will happen eventually, you will be able to understand all the complex logics which are possible in DSA itself. Okay, so that's why we were following a completed sequence. Right now, what we are doing is the math. We know already, right? And we have already solved two questions, right? Now, today, what we'll do is that we'll solve a third number question, which already has been asked in multiple companies. You'll see the company name on the thumbnail as well in the description also. Okay, so now here the question is factorial trailing zero. Factorial, and I guess this has been asked in Facebook, Amazon, Bloomberg, and other companies too. Factorial trailing zeros. Question number, this one, 127. And again, if you will see the difficulty, if you will see the success rate, like how many people were able to submit their code in the attempts. So you'll see right here. You'll see right here. Factorial trailing zeros, where it is 44.3%, means less than the half of the people who were attempting it. Right? So which is very few, right? Like let's suppose there are 100 people who are trying to submit the solution, only 44 point something people have been able to solve this problem, right? Why? Because there's something which is hidden, and I'll tell you what. Okay, now clicking on the question and look at it, right? Read the problem for a minute. Read the problem what has been given. Factorial trailing zeros means that given an integer n, return the number of trailing zeros in the factorial of n. Let's say we have a factorial of 5. So what we'll do is that we'll find the factorial of 5 is 120, and at the end, trailing means at the end the zero is 1. So that's what we need to return. That's what we need to return. Like how many zeros we will get at the end. Okay, that's what we need to return. Yeah, again, what I'm seeing is that there are very few people are just joined and other people are not interacting even. Kanaji, do one thing, share this video with your friends as well. Huh? They should also get benefit from it. So now here, look at this problem. Here, if n is 3, we know that how to calculate a factorial. If factorial is 3, so what we'll do is that 3 multiplied by 2 multiplied by 1. Every time we reduce a one digit, one number, and keep multiplying it, right? We'll get the factor, which is 6. There is no zero at the end, yes or no? For the factorial of 5, what we will do is that 5 multiplied by 4 multiplied by 2 multiplied by 3 multiplied by 2 multiplied by 1. Right? The value will be 120. At the end, we are getting 1 0. So that is the meaning of trailing zeros. So after calculating the factorial of a number, how many zeros we can have? Now think about a basic approach. Okay, think about a basic approach, like how we can attempt this question. So somebody can say like it's a super easy one, super easy method that we can do, and that is like first we can calculate the factorial. What we can do first, we can calculate the factorial. So let's see method one. Okay, calculate factorial, and then do one thing, divide by 10, and the number of times you'll be able to divide it by 10 and you'll get the remainder 0, the number of 0 you will have. For example, we had the factorial of 5, which is 120, and you will divide it by 10. Only once you can divide it, because next time it will become 12, right? And again, if you will try to divide it, you won't be able to divide it. Why? Because that time the remainder will be 2, not the 0, right? So again, what we can do is that we can calculate the factorial. We can divide by 10, right? And until unless we are not able to divide the number further, we can say like how many times we have divided, that is the number of zeros which will come just after the digit, after calculating the factorial, right? Yes or no? So now here we can say we were able to divide once, so the number of 0 will be 1. The basic logic, super easy logic. But the problem is when you will go to the constraint part. I'm showing you something. When you will go to the constraint part, they tell you like the value of n will be 10 to the power 4. The possibility, right? And you know that if we calculate the factorial of bigger numbers, that is not a possible to calculate even. The number is very huge, right? So again, because of this large number of set, this is not possible to calculate the factorial. So now we have to figure out a logic by which what we can do is that we can get the number of trailing zeros even without finding the factorial value. Yes or no? Yes or no? Right, Mansi? And other thing, I do one thing again, because only 9 people, I guess, are watching the video as of now. Do one thing, share with your friends as well, yeah. I want at least good people, a good number of people. Only then this hard work sounds to be good. Right? Yeah. So now the one logic was to calculate the factorial, then divide by 10. And when you will want to be able to divide it further by 10, which means we can say the number of times we have divided, that will be the trailing zeros, right? Again, that is not possible because for the larger number, we cannot count the fact, we cannot calculate the factorial, right? That is not possible. So what we have to do now, the another approach is we have to calculate the factorial even without finding the factorial, right? We need to count zero zeros without finding factorial. Factorial, yes or no? That's what we have to do. That's what we have to do, right? So now what we can do is that there are some already written patterns which we need to identify. But I'll tell you the basic logic. Okay, I'll tell you basic logic to understand it. For example, we have 5. Okay, how will you calculate the factorial of it? Tell me. You'll say like, sir, I'll write 5, 4, 3, 2, 1. Yes or no? If I ask you how many zeros you will get at the end of this calculation, you will say like 1. Why? Because you will get 0 only in a one situation where 5 is multiplying by 2. Yes or no? Right? When you will multiply 5 by 2, only then you will get 0. So if I ask you that the one method can be the solution number 1 can be the factorization way. Why? We will count like how many fives and how many twos are there in the number of factors, or in the number of values from that 1 to n, right? That 1 to n. So now we'll count that the number of 5, the number of twos from 1 to n. We'll count the number of 5 and number of 2. And again, the minimum, because you'll get the 0 only when the 5 and 2s are equal, right? So now again, if there are, let's suppose, there is a number 10. There is a number 10. So how many zeros will be in the factorial of 10? So now how you will calculate? If you will see this, you will find a value which is 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 2. Again, what? Multiply by 1, right? Multiply by 1. So now you'll see that you can divide this by 5 and 2 as well, right? So 1 5 is here, or 1 2 is here, yes or no? Another 5 is here, another 2 is here. So now we have 2 5 2 2, means we will have 2 zeros. Yes or no? Means we need a pair to find the zero. Right? We need a pair to find the zero. Making sense to you? We need a pair of 5 and 2 to get a zero. Right? So that's what we have to do. What we will do is that we'll run a loop from 1 to n. Again, we will check if in between we get something which can be divided by 5. We'll count the number of 5, we'll count the number of 2, and then the minimum value means the minimum value. If let's say there are 5 2 and again there are 3 5, so how many pairs will be possible? 3 only, because 5 2s, right, and 3 5s. So now we have the common value which is 3. The minimum value of both will be the number of zeros. Yes or no? Making sense to you? So that's what I'm thinking is that what I can do, I'll go to the code screen, I'll show you that what we can do is that we can count the number of 2s and number of zeros. Yes or no? Now count int, I'll count the number of zeros and number of 2s and number of 5s. So let's say number of 5, I'm writing NOF, number of 5, right? At initially I'm assuming it's a 0. Again I'll count the number of zeros. So I'm assuming, number of 2s. So number of 2s, and not, wow. Okay. So now what I'll do is that I'll run a loop from I equals to 1, not 0, because every number is divided by 0, right? And that will cause infinity. Now should be equal to n, again I plus plus. Now here what we can do is that we can calculate the number of 5 and the number of 2s. Yes or no? So now here for that purpose I'm creating a variable num, because I should be independent to run the external loop. We cannot have a dependency on I. So I should be independent. So now that's why I'm taking the record of I. Now what I'm doing is that if that particular range, that particular number is divisible by 5, will increase the count of 5. Yes or no? So if number is divisible by 5, then we can say we got one digit which is 5. So we can say like number of 5 should be plus plus, the value should be increased by 1, and again what we want is that the number should be reduced by 5. The means we should also divide the number by 5. Yes or no? To reduce its overall value. So now again what we'll do is that number should be become the 1/5 of it. Yes or no? Now for calculating the number of 2s, similar thing we can do. While the number is divisible by 2, right, we can say like there were availability of 2. Yes or no? So now not plus plus, number of 2 plus plus, and again we will reduce the number by half of it. So number by 2. Yes or no? And the common value will be the minimum value. Whoever will be in the less quantity, that is the common value. Yes or no? The common of both. So now what we can do is that we can use the existing method to calculate the minimum value, and that is what math dot minimum to calculate the minimum value. Yes or no? And we want to return it as a final output. So now here we can say the number of 2 comma the number of 5, right? Whatever will be the minimum common value, that will be our final output. Yes or no? So now run this, and I'll try run this as well to explain you how these things are working. Right? It's correct, and I'll tell you the another approach as well. Okay, so don't worry. I'll tell you another approach as well, because this is the basic logic. Whenever somebody sees the problem, they can calculate this basic logic. But as you can see, this solution is taking a lot of time. because when the n will be the 10 to the power 4, that is a very, very huge number. And what we are doing is that we are running an external loop. Look at it. Look at this. We are running a for loop, then inside there are while loop, right? So time complex is really high. Yes or no? Right. So now again to optimize it, there is a pattern that I will tell you. But before going on that pattern, we'll understand this solution, how this is working. Okay, how this is working. And I want to tell you, look at this. We'll take some random input value which are already given here. Okay, I guess I can scroll it a little more to check some test cases which are already given. Okay, there's nothing given here, but that is fine. Okay, we will take something. Okay, we'll take something here. So now here, look at this. For example, if we have n is equals to 5, if we have n is equals to 5, then how many zeros will be in the factorial value, right? That we want to calculate. Yes or no? So now at starting, we're assuming number of 5 is 0, number of 2 is 0, just assuming, right? Again, what we will do is that we will check like what will be the numbers till 1 to 5. If we are getting the number 5 and 2, we'll count them, right? And that will be the number of zeros, because 5 multiplied by 2 become 10, right? And 10 always produce a 0 at the end. Yes or no? 10 produce a trailing 0, right? So now here, what I'm doing is that, this is an important thing. I have done this because if I have divide I here, it will reflect, it will affect the external loop as well, because the existing value will be I plus plus. So what I want is that I want I should be independent. Now for starting, let's say I is equals to 1, then num will be what? N will be 1 here. Now we'll check like, is 1 modulus 5 is 0? No, this is not true. So that time this while loop will not execute. Again, we'll check for the like num modulus, that 1 modulus 2. This is also not equal to 0. So again, this will be, skipped. Now again, what will happen? I plus plus. That time what we will have? We will have n is equals to 2. Is 2 modulus 5 is equals to 0? No, which means this condition is not true. If this is not true, we will skip this while loop. Yes or no? We will skip this while loop. Again we'll see here, we'll check like if this num n is equals to 2 modulus 2 is equals to 0. Yes, this is divisible. This is divisible. Yes or no? If this is divisible, then what will happen? Not plus plus means number of 2, we have got 1 2. Yes or no? So now not plus plus, now we will have the value of not here, which is equals to 1. Yes or no? Because previously it was 0, now it has become 1. Right, now I want to divide that number by 2, because anyhow we have to 1 digit from its multiplication. From its multiplication, we have to 1 digit. From where you're getting this? Look at this. We have got this 2. We have got this 2. Now you have to divide this whole number by 2. Yes or no? So now that num, which was previously 2, has become now what? We have divided 2 by 2. This becomes 1. This becomes 1. Again, we will check, is 1 modulus 2 is equals to 0? No. Which means this while loop will be exit. Right? This will be skipped again. So now again what will happen? I plus plus. This time we will have n is equals to 3. Sorry, I is equals to 3. Right? I is equals to 3. Because previously it was 2. So now here the value of num will be 3. Yes or no? We'll check, is 3 divided by 5? No. Is 3 divided by 2? No. And what will happen? I plus plus. Now I becomes 4. When I becomes 4, then num becomes 4. If num becomes 4, is 4 divided by 4? Is 4 divided by 5? No, it's not true, right? So we will skip this while loop. Again, we'll check, is 4 divisible by 2? Yes, it is, right? So now what will happen? Not plus plus means now the not value of not will be 1 plus 1 means 2. Yes or no? Again, we'll divide the number. So now number is 4. 4 divided by 2, which means num becomes. It is not right. So now what will happen? We'll exit from this loop. Again, we'll go on the top. I plus plus, the value of I becomes 5 here. The value of I becomes 5 here. So now the value of num will also become 5. We'll check like, is 5 modulus 5 equals to 0? Yes, 5 is divisible by 5. Yes or no? So now what will happen? The number of 5 will be plus plus, which means we will have number of 5 as 1. NOF is 1. Now what will happen? We'll divide 5 by 5 because the value of num is 5. So now this will become 1. Is 1 modulus 5 is equals to 0? No, it is not. Then this while loop will be terminated. Again, we'll check here. Is 1 modulus 2 is equals to 0? No. So this while loop is also terminated. Again, what will happen? I plus plus. Now the value of I becomes 6. Is 6 less than 5 or equals to 5? No. 6 is greater, which means this for loop also will be terminated. Now we want to check the pairs. We want to check the pairs. Yes or no? We want to check what? We want to check the pairs of 2 and 5. So there is a 1 only 5, number of 5 is 1, and number of 2 is 3. Why? Because 2 are here and 1 2 is here. So number of 2s are 2, only 1 5 is there. So now what will the number of zeros? Only the combination of 5 and 2, which means the minimum value of number of 5 and number of 2s, which is 1. Which is what? Which is 1. Because why? Because you can only multiply 5 by 2 to get 10, and 10 will add up, trailing 0. Yes or no? So now the number of zeros will be the minimum value between number of 2 and number of 5, which is 1, and the final output will be 1. So any number you can calculate it. So here is a given task to you. You can try for 25 as well. Take n is equals to 25 and run it, and understand how this whole solution will work. And I hope you understand the basic logic behind it, that factorial will have at the end the number of zeros only the combination of 2 and 5, right? Because you can find a 0 at the end only when number have a combination of 2 and 5. Make sense to you? Yes or no? Make sense to you? Right. So now again, what we have, we will plan another solution. Another solution that is a pattern. Okay, there is no logic directly. That is a pattern which who somebody has figured out, right? So that is a somebody else work, but there is an existing pattern. What we can do is that if you want to find out the number of zeros, what you can do is that you can divide that number by 5, and whatever the remaining number is, you add in the count and keep doing it. You'll get the number of zeros, number of trailing zeros. But that is a pattern, that is a trick which you need to remember. Previous one was the logic, right, which you can figure out from the solution, from the code itself, from the problem statement itself. But another one is a trick, another one is a pattern which you need to remember, that there is existing a pattern. You want to figure out the number of zeros for a factorial value. So what you can do, you can divide that number. For example, we have a number n is equals to 25. Okay, so if you want to calculate the number of zeros in the factorial of 25, what you can do, you can divide this number, you can divide 25 by 5. Okay, and you can have the output in the count itself. So now let's say I'm assuming at starting the count is 0. Here I'm updating the count plus equals to whatever the number, whatever the n by 5, and next time I'll update this n divide equals to 5. Okay, so now what will happen, what will happen this time, what will happen when they're starting here, you need to do this, or previously also you can do. So now here count plus equals to n, that also works. Okay, so now what will happen, let's say we have n equals to 5. Now what will happen, you will take n equals to 25 by 5, which means 5. Yes or no? Which means 5. Yes or no? So now here the value of count will be what? The value of count, previously it was 0, so 0 plus 5 is 5. Okay, now because n has become 5, we'll keep doing this until unless n becomes 0. Okay, so we'll keep doing this when the n is greater than 0. So now 5 is greater than 0, which is this n is equals to 5 is greater than 0. You'll repeat this process again, which means you'll write here n is equals to 5 by 5, which means 1. So count will be previous count, which was 5. 5 plus 1 becomes 6. Yes or no? Now the value of, or you can say 1 also. Okay. Yeah. So now what's happening is that, again you'll see here, you won't get anything. So now here what you can see, like n becomes 1. N becomes what? 1. Now you'll see is 1 greater than 0. Yes, it is. So now you'll come again, you'll divide 1 by 5, which becomes 0.2, right? But 0.2 will convert into the integer value, become 0. Right? You'll add the 0 in the count and again you will see like a 0 greater than 0. No, it's not. Then what will happen? The loop will be terminated. You will have the number of zeros. The count will be the number of zero. For the 5, you see that you will get the number of zero is 1. So that is a pattern. That is a pattern, not a solution. Okay, that is a pattern. You need to remember, not the logic directly. So again, we'll code for that as well. We'll code for that as well, and we'll wrap them. So now here I'll tell you the another solution. So let's say I have a count which is equals to 0 as of now. So what I'll do is that I'll run this solution until unless number is greater than 0. And again I'll calculate, I'll divide this number by 5, and I'll keep dividing it. And now every time I'll add that result into the count plus n. Okay, so this will keep happen until unless n becomes 0, right? So in that case we will stop executing it and we will return. But that is a pattern which you need to remember. It's not a direct logic. Okay, so now here what we can do, we can run this, and this is faster than the previous one. Why? Because here we are applying this one loop, right? Super faster than the previous solution. So the optimization, if you can remember, so that is fine for you. You know the logic. You have to remember, like if you have a if you want to find out the number of trailing zeros in a factorial value, so what you can do, you can divide that number by 5. Whatever the output is coming, you can add into the count value and keep doing it. At the end, you'll get the number of trailing zero. But that is a pattern. Solution one was the logic which we were trying to find out from the problem statement itself. But solution 2 is a pattern. I hope you enjoyed this. If you have any particular doubt, you can ask to me. Otherwise, we can wrap this live. Okay, I don't think so. We have a lot of doubt. Now we can wrap this live. Okay, guys. Bye bye. Thank you for joining. And again, you also try this problem. Try to solve this problem by yourself as well. Okay, try to read the problem, try to understand it, and solve it. Now I'll close this live. Okay.